A very good morning, dear participants. Welcome to this day four on the 1 week online FDP on learning through virtual labs for technical institutions. I hope you are learning much from all these days. Today, we are glad to have Professor K.V. Gangadharan sir with us, who will be leading us on the topic Transdisciplinary Learning Initiatives by NIT K. Surathkal, followed by the continuation of yesterday's session on the demonstration and overview of virtual labs for core engineering domains, which will be taken up by the team at NIT K. Surathkal. So before I give this time to Sir, I request my colleague and coordinator from the department for this FDP, Mr. Pradeep Kumar, to introduce Sir and hand over the session to him. Over to you, sir.
Thank you, Daniel, sir. Good morning, one and all. I am M. Pradeep Kumar, Assistant Professor, Department of Mechanical Engineering, Delhi Institute of Engineering and Technology. I am profoundly delighted to introduce today's speaker for the first session, Professor K.V. Gangadharan. He is a professor in mechanical engineering and head of the Center for System Design, NITK Surathkal. He has earned his PhD from IIT Madras in the year 2001 in the area of railroad vehicle dynamics, and his master's is from NIT Trichy in the year of 1992. He completed his bachelor's in mechanical engineering from Calicut University in the year 1989. His areas of research include system vision vibration and its control, smart materials and its applications, structural health monitoring, and product design. He is also actively engaged in creating learning materials for experimental learning of basic concepts in engineering. He has teaching and research experience of 27 years and industrial experience of 1 year. He is actively engaged in industrial consultancy and sponsored research projects and has more than 120 research publications to his credit. He has filed 7 patents, 4 in the area of medical devices and 3 in smart material applications. An active HAM amateur radio with a call sign of VU2TAO in charge of amateur radio facility at NIT Surathkal. Sir, we are pleased to have you with us today. I request you to kindly take over the session, sir. Thank you.
Thank you. Thank you everyone, Pradeep and Daniel, for nice introduction and getting me back, rather forcing me back. So good. Let us see, today we should be looking at something slightly different from what virtual lab we were talking all around. But this is a continuation of the same, but with a different flavor, because we were looking at how do we impart experiential learning in a multidisciplinary environment. Or that was the initial stage when we went to say that, okay, it is not just a multidisciplinary, we have to get into transdisciplinary. So I will request each one of you to check with what is multidisciplinary, what is cross-disciplinary, interdisciplinary and transdisciplinary, because we will not discuss much on that, but we will just tell you what is that we were trying out. And that's what I am trying to do there. Is there an echo coming in?
Yes, sir, slightly.
That is
Not much, but yeah.
No, I had one system wherein, okay, I will leave it to you to, if something is not coming there well.
Now it's now there's a disturbance, sir.
I will log out of the other, because there I am not able to keep the volume 0.
Okay, sir.
I will leave that. And so one of you have to tell me whether there is any issue, so that other system which I had logged in, I had taken off, so that you can tell me if my PPTs are not coming through. You need to tell me, because it will have quite few things to look around. So
yes, sir. Sure, sir. I'll let you know.
Yeah. So I'll present my screen. Is the presentation coming up?
No, sir. I
Not
think
yet, sir.
yes, sir.
Yeah, no, it's
Yeah,
Yes, sir.
yeah, thank you. So on behalf of NADK Surathkal, and warm welcome to a different kind of an experience to look at experiential learning. So the slides which I'm going to present was ably made by Dr. Prithviraj Umesh, an associate faculty for Center for System Design. We were looking at experiential learning. I'm trying to hide something here, which was, there's no way to hide this. Experiential learning, a transdisciplinary approach. So we wanted to look at different domains, putting it together and providing our students an experiential approach. So we went around looking at terrain and landscape. That was one part, wherein all the students who are involved are from different branches of engineering and science. Some of them are not even engineers. We had people coming from different parts of different streams of studies. Then we had the difficulty as well as the opportunity of COVID-19, wherein we started making use of all the available experimental facility meant for research to be useful for the community in case of such a difficult situation. So that was our next approach. Then all of us had to be at home and have to do the classes. And we were looking at how do we make virtual reality possible for a student who is in a remote place. He cannot just afford to buy a headgear. How do we do it, and how do we make him enabled to use his own mobile for such application? Then it came to e-mobility and unmanned aerial vehicles and drone, etc. So all this, some of these things which we will present today to show you probably how each one of you can look at multidisciplinary to transdisciplinary move of doing research. Not necessarily research, it could be even a small mini project given to your own third semester students, wherein you ask them to go and look around and find problems and find, in order to get the solution, what all domains are required. There may be a person who is required to come in from an economics background. There could be a sociologist which may have to come, or there could be a person who knows about administration need to come, or government policies may have to come, and you may have someone from engineering or technology background also to be there. So all that kind of a work is what we are trying to present. It will be a set of videos and presentation together. You can sit light, and this is going to be something which you will experience as a video show rather than a talk as such. So we were looking at how do we excite our students and which part of the technology is driving them to get in. And here we were also looking at people who can do engineering. It is not just about, because whenever we say exciting the students, people will tend to think AI, ML, data science, and things of that kind. Obviously, that will excite. We wanted that along with some manual activity or experiential activity to be happening. So what you see on the screen now are our own e-vehicle approaches which we have done. I will explain one by one and tell you what is that we intended by this activity. So the entire e-mobility at NADK, driven by Center for System Design, how did we look at it, and what is the philosophy? How did we bring together the transdisciplinary concept into it is what we are looking at in next few slides. So we had different kind of design approaches. Our young students are interested to have some risk. Of course, they love to take risk. So we said, okay, e-scooter where student can stand and ride is one. Then we had some requirement in the institute. The resident engineer, that is our SRE establishment, we call it as a resident engineer, where the entire the real what do you say, the land, buildings, and all the maintenance, etc. They take care. We wanted them to use, because we saw per day few of them are riding their bike more than 600 kilometers per day. So we were just looking at, is there a possibility to convert that into an electrical vehicle? So electrical vehicles are available in the market, but how do I use this opportunity to give my students an excitement of creating something and learning from it? So that is what we did. We did. Then we saw the dispatch clerk, dispatch person, the peon or the office boy who runs around from building to building with files. He is also traveling almost 100 kilometers per day. I mean, at least 6-7 times he have to do this dispatching, and from one building to other building there will be some files to be moving. And in in Mangalore it is a heavily raining area where he has to carry it, whether he has a scooter or a cycle, he need to carry all that. So we were looking at that as another possibility. Then the students who don't want to take that kind of a risk of standing and riding wanted to give the comfort of a normal cycle. So that was the next. So let us see how we looked at it and how the concept was converted to reality. So first we asked the person, a few groups, to go around and talk to people and find out what is the requirement. And these requirements are conceptualized, and an artist was asked, and he's not an engineer at all. He's just an artist who could picturize the words. And he did this artistic approach. Of course, it's all digital art. And from the statements the students, the users have given, he was trying to visualize what is that they have in mind. It has no engineering in it, remember. So when you explain what is that you want, you ask a lady to explain what kind of sari or a dress material they want. They will give you verbal instructions. And if you're good at picturizing it, I'm sure that all husbands will be feeling happy if they could picturize it. Whenever they get some item, they say, this is not what I had in mind. Even though I told you very clearly what I want, you did not catch what I want. And when you get an item, probably it may not match with the descriptions probably the person has given. So this was one revealing information for an engineering students. When somebody talks about an idea, this is what they required. How do we capture that information, convert that into part of the product? If you make a great product, but the user don't like it, or the user feel it is useless because what they had in mind is not what you have made, then how do we convert? How do we reduce that gap? It is not the engineer who have to do it. It has to be a person who are able to visualize verbal instructions in the graphical domain. And there, if you have less and less technology input, it will be much better. The people could grab more non-verbal communications, convert that into images, and put it as a picture is what we are looking at here. We are not looking at an engineer at all. And I strongly suggest not to have an engineering student to draw the sketch. Probably they will be able to really do well in this, but at the same time, we want someone who is not constrained by technology to be using this. So that was our first activity. And again, for each of this, I'm just giving you all the details, but just putting in few things together to show you activities, how we went about. So this was the concept diagram which the artist formed. Of course, he may not be knowing how the wires to be taken, what to be done, etc. But the pictorial view. Then on that, the technology students sat together. How do we do that? How do we manufacture? So first impression informations are written on the sketch itself. What you see on one side where written materials are there, wherein they have written, okay, if this is to be made, I will go for 3D printing. If this have to be done, I'm going to do it like this. I want each of these to be of what material, etc. Again, we haven't got into full technology. It is still in the concept level. Then from there we got it, and of course we had some press release and things of that kind. This is just to give you a feel of what is that we made. It is 55-kilometer range. Of course, it is geo-fenced. It can run only within NITK. As soon as you move out of NITK, it will switch off. And 250-watt BLDC motor we have used. Obviously, I will tell you at the end what is that we have. We are looking at as a driving element to be done as a research part. We use a 28Ah lithium-ion battery in this case, and we have a student-made ERP solution for NITK. We call it as IRIS. That is our student management system, as well as the entire administration, etc., are being digitized using the student-made ERP solution for NITK, which is called IRIS. And we are integrating all this with IRIS so that the person who can come and just scan a QR code and get things moving. So that's how we are hoping things will be done. In fact, we could request our own director to ride and see how it is. This is the dispatch vehicle which we made. We also tested for, because this, what happens is once it is made, the design stage, from concept to design and integration, electronics, electrical, mechanical, the manufacturing group, all that put together, and we had some material issue, the material students or metallurgy students, all of them coming together and working to produce something like this. It is not only, it is just not an what you said, student project as such. It is something they have to see running for few years. So that means they have to look into reliability, and if they have to produce more and more components, there should be standardization happening. So it gives them a feel of an engineering workflow from the user perspective to the final product and marketing. So, and it is actually a transdisciplinary activity. So we also had some paper issues, all that. Then this is the last one which we shown you in the picture, how the concept diagrams were made, and this is the final product. We call it as video 3. It is a pedal assisted riding mode. You can also use pedaling, and this is what we are looking for to make. We have made one for the security, and then once we made one, we also got some requests from forestry to try out some designs for forestry. You can see the artist make it in his own way, and whether we are able to make in a similar fashion or not depends on engineering feasibility. But he grabs the information from the user and put it as a concept diagram. And this is another one which we are looking at as a van. This is still in the concept stage. And another project which we have put along with it is Urja, the solar charging stations for all the e-vehicles. This is all activity within NITK. But here the point is, it is not about what we did, it is about why we did it and how are we putting that experiential learning part in that. So that is more important for our FDP now. How do we provide that experiential learning part? How do we make our students to work together in a transdisciplinary environment is what we are looking at. So here we had an opportunity. Many of the students who are good at digital manufacturing, additive manufacturing, and design and things of that kind, they came together and started making things. So the concept diagram had all this, and we started making items using our available 3D printers. And we also have a research project going on, switched reluctance motor. Those who are from electrical or electrical machine side will be knowing. SRM switched reluctance motor is supposed to take over all BLDC approaches, but there are sufficient amount of unsolved research problems. That's why no company could come out with an SRM in a production. Many of SRMs are available in laboratory scale, and they are able to try it out. We also do have a few items which we have purchased, but we are doing an active research on SRM and its control. We are hoping that one day we will have our own SRM motor coming in all these vehicles. And electrical, electronics, and IT and CS students, how do we put them together with a group from GIS, that is those who are from civil engineering branch. So we wanted geofencing. So geofencing is a concept, and within a geographical location, things have to happen. And it is very well used in drone technology. We can make sure that the drone is not moving away from a geofenced area. All that is possible, but we wanted to introduce that to a vehicle like this. And that also we could do it in a great extent. Of course, the reliability testing is going on now. This is a bike we made for the forestry. From the concept diagram, we did a Dr. Prithviraj and team went to Kudremukh National Park and had almost 4 days of rigorous tests. And remember, there will be no charging station available in the deep forest. So they had to carry their own battery pack as well as solar cells in the forest. In fact, the vehicle which you see used to trolley the batteries are also made in Center for System Design. So it became a requirement. The students are working on it, and next week we need to go and do this. So the problems are listed down and what solution can be done. So we had some wheels here and there, all that put together. Quickly they assembled a trolley. They themselves designed, tested, and few quick finite element analysis were done. Whether, because remember, some 12 kilometers we may have to trolley this in the forest, and it's not a nice road, and still it should withstand. So it become more an involved experiential learning activity for different kind of students together. Then there were a few students who are excited about virtual reality. We have a team working on virtual reality. We said, then when you made one cycle like this, why can't you make a virtual reality app wherein the cycle assembly can be converted to a virtual reality training kit, so that one set of students who make one cycle or one set of cycle can go to next level and start doing much higher tasks, and the newcomers can do the assembly. And how do we train them? We want to train them using virtual reality kits. So successfully they have implemented this, and 1 or 2 products we are able to demonstrate how to implement the, how to get the this the assembly done together. So that is about one item which we did for providing experiential learning in a transdisciplinary mode. So I'm sure that all of you heard a lot about autonomous vehicle, autonomous activities. Look at trying to do in an autonomous vehicle on a road have its own challenges. Then we had some requirement from both Udupi as well as Mangalore region. All the sand mining activity need to be monitored, one, and the sanction need to be given. So we need to do a bathymetry survey. Those who are from civil will be knowing how much deep the sand mine can be done. We need to do sampling of sand and the items available, how much sand and clay is available, and how much can be mined, etc. So normal method is hire a boat, go, and it takes huge amount of time to do it. We said, why we need 3 people sitting in a boat and going around for such a simple task? We said we will make it autonomous. And remember, in this case, autonomous activity is much better because it is easy, not much of an obstructions. It is easy to drive, and not necessarily it should be autonomous. It can be driven from outside. And this work had a huge contribution from water resources and ocean engineering department, where Dr. Prithviraj works. So I'll just show you one video that should be, let me see whether. In this demo, we are not going completely autonomous. There is a person who is going to override if required. This is a manual override. Earlier, what I have shown is an remote override. Few pictures how Remember, this is not like our normal project. The students have to literally do a lot of things, and including how to transport this to the testing site and the logistics, how to put it in water. It's quite involved work, and it provides a lot of courage to the students to take up activities. And obviously, it is also really challenging for the faculty members, also those involved, to get such things moving. And we had very strong students who were dare enough to venture into many of these activities. Hence, we could do many of these things. And at the end, after making this, we had one of the professor who working in this area, Professor Paresh Chandradeka, who circumvented to leave this place due to COVID. So we dedicated this to his name. He was from Assam. So that is about marine vehicle, autonomous vehicle. I shown you an electrical vehicle, then a marine vehicle. Now, can you imagine NITK taking construction management in Jammu and Kashmir? Look like a laughable item. So we take up activities which when we keep telling, others should feel like laughing at it. Then we get a lot of energy from the laughter from others. So we convert that energy of laughter into our activity to make it happen. So IIT Jammu is on 480-acre campus, but very treacherous campus. I think 4 or 5 hillocks and loose soil and very prone to slides. There they have to construct these buildings. So when we interacted with them, we found out there is an opportunity to do a lot of aerial survey, both on photogrammetry as well as LiDAR survey, and converting that into terrain maps, surface map, and digital DSM and contour map and all that for all the civil engineering application. Then they also wanted to do the construction monitoring and converting the progress each of the stage into a 3D model. And what you see here is the picture which we have taken through combined using a drone, using a photogrammetry approach, and we also did for the LiDAR approach, using the LiDAR. Those who are not familiar with these terms can keep searching afterwards, note it down and search for what does it mean of LiDAR and photogrammetry, etc. So we created a 3D map which can be zoomed to 1 mm level. That means if whatever you see on this picture, I can go and zoom on the software, find out whether the item lying there down is 1-inch pipe or 2-inch pipe, or these solar panels, whether they have put it correctly or not. I can zoom and see individually. I don't need to go there because it's our images taken by drone with a specific format, specific way. That is, it's called a vision plan, wherein each pictures are taken and overlaid, and this can also be overlaid on a Google map. Using a Google engine, it can be overlaid, and it works quite well with that. Let me just see whether I can show you one demo on this. So this is an photogrammetry 3D model. Remember, what you see is not the picture. On a software, I should be able to go deep in. I can cut parts. I can find out the filling requirement, cutting requirement, etc. So those who are from civil will realize how important it is. So these kind of hillocks, it has to be leveled. Of course, the rest of the portion we have not shown there. It's only 25 acres. What you see here is only 25 acre. You'll also see that Jammu Srinagar highway going there. So after making this 3D model, most of the board meetings or high level meetings, the time available for you to explain the progress will be limited. So we could give them 3D model of progress. That is, what was the ground level, what is presently, and etc. So that others could just touch and feel what progress they made. That really helped a lot in many cases to explain quite a bit about the activities progressing. So we also had a lot of opportunity to work with Karnataka irrigation department. let me see whether I can show you a video. It should open in.
KR ಸಾಗರದಿಂದ ಡೆಸ್ಕ್ ಸ್ಟಡೀಸ್ ಮಾಡಲಾಯಿತು. ಈ ಡೆಸ್ಕ್ ಸ್ಟಡೀಸ್ ಮಾಡಿದ ನಂತರ ನಮಗೆ ಇಲ್ಲಿ ಒಂದು ಹೆಚ್ಚಿನ ಮಾಹಿತಿ ಬೇಕು ಅನ್ನೋ ಒಂದು ಭಾವನೆ ಬಂದಿದ್ರಿಂದ
it is in Kannada because it is for Karnataka government, so we are also getting it in English.
ಇವರ ಸಹಯೋಗದೊಂದಿಗೆ ಒಂದು ಶೋರ್ ಲೈನ್ ಚೇಂಜಸ್, ಈ ಒಂದು ಎಸ್ಟುರಿ ಭಾಗದಲ್ಲಿ ಶೋರ್ ಲೈನ್ ಚೇಂಜಸ್ ಒಂದು ಅಧ್ಯಯನವನ್ನ ನಾವು ತಗೊಳ್ಬೇಕು ಅಂತ ಅವರ ಜೊತೆ ಒಂದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಬಂದು ಅವರ ಸಹಯೋಗದೊಂದಿಗೆ ಈ ಒಂದು ಅಧ್ಯಯನನ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ.
You can give a chance, you can provide a chance to the students to do an actual implementation. So they also get a chance to interact with the local people, get the input, convert that into technical activity. He is talking about what problems he faced when there was an intrusion, etc. So he's telling that many houses have been destroyed because of this, and we need a solution.
ಇದು ಅತಿ ಅವಶ್ಯವಾಗಿ ನಮ್ಗೆ ಆಗಬೇಕು, ಯಾಕಂದ್ರೆ ನಾವು ಪ್ರಯತ್ನ ಮಾಡ್ತಾ ಇದ್ದೇವೆ, ಪ್ರಯತ್ನ ಸಫಲ ಆಗ್ಬೇಕು ಅಂತ ನಮ್ಮ ಆಸೆ ಇದೆ. ಆದ್ರಿಂದ ನಾವೆಲ್ಲರೂ ಇದನ್ನ ವೀಕ್ಷಣೆ ಮಾಡಿ ನಮ್ಗೆ ಅದು ಬೇಗ ಇದನ್ನ ಆಗುವಂತ ತಡೆಗೋಡೆ ಆಗ್ಬೇಕು. ಈ ತಡೆಗೋಡೆಯಾಗಿ ನಮ್ಮ ಜನರ ಜೀವನ ಮತ್ತು ಅವರ ಪ್ರಾಣ ರಕ್ಷಣೆ ಆಗುವಂತ ಕೆಲಸ ಆಗ್ಬೇಕಂತ ನಾವು ನಿವೇದನೆ ಮಾಡ್ಕೊಳ್ತಿದ್ದೇವೆ.
So when students get involved in this activity, they also learn about how do we visualize, how do we put things together, how people look at different problems, and what technical solution probably can be given in order to get such things.
ತುಂಬಾ ಹಳೆ ಔಟ್ಡೇಟ್ ಆದಂತ ಇಮೇಜಸ್ಗಳು, ಪಿಕ್ಚರ್ಗಳು ಸಿಗ್ತಾ ಇರುತ್ತೆ. ಈಗ ನಮಗೆ ಲೇಟೆಸ್ಟ್ ಇವತ್ತಿನ ಈ ಮೊಮೆಂಟ್ ಇಲ್ಲ ಅಥವಾ ಒಂದು 15 ದಿನ ಒಂದು ತಿಂಗಳಿನ ಹಿಂದಿನ ನಮಗೆ ಪಿಕ್ಚರ್ಗಳು ಬೇಕು ಅಂತಿದ್ರೆ ಹೀಗೆ ಡ್ರೋನ್ ಅಥವಾ ಅನ್ಮೈನ್ಡ್ ಏರಿಯಲ್ ವೆಹಿಕಲ್ UAV ಯೂಸ್ ಮಾಡಿ ನಾವು ಇದನ್ನು ಪಡೆಯಬಹುದಾಗಿರುತ್ತೆ ಹಾಗೂ ನಮ್ಮ ಮುಂದಿನ ಅಧ್ಯಯನಕ್ಕಾಗಿ ಇದನ್ನು ಉಪಯೋಗಿಸಬಹುದು.
So he just explained how it can be used.
ಡ್ರೋನ್ಸ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಇದರಲ್ಲಿ ನಮಗೆ ಸೆಂಟಿಮೀಟರ್ ಲೆವೆಲ್ ಕರೆಕ್ಷನ್ ಸಿಗೋದ್ರಿಂದ ನಾವು RTK ಅನ್ನು ಅಳವಡಿಸಬೇಕು ಅಂತ ಡಿಸೈಡ್ ಮಾಡಿ ನಾವು ಇಲ್ಲಿ RTK ಯೂಸ್ ಮಾಡಿ ಪೊಸಿಷನಿಂಗ್ ಮಾಡಿದ್ದೇವೆ. ಗ್ಲೋಬಲ್ ಸ್ಯಾಟಲೈಟ್ ಯೂಸ್ ಮಾಡಿ
ಮಾಡಲಾಗಿ NITK ಯಲ್ಲಿ ಲಭ್ಯವಿರುವ ಫೋಟೋಗ್ರಾಮೆಟ್ರಿ ಲೈಸೆನ್ಸ್ ಸಾಫ್ಟ್ವೇರ್ ಮುಖಾಂತರ ಈ ದಿನದವರೆಗಿನ ಅಪ್ ಟು ಡೇಟ್ ಏರಿಯಲ್ ಇಮೇಜ್ ಇಂದ ಜಿಯೋ ರೆಫರ್ಡ್ ಮ್ಯಾಪ್ ಪ್ರಿಪೇರ್ ಮಾಡಿದ್ದೇವೆ. ಇವುಗಳಿಂದ ನಾವು ಉತ್ತಮ ಗುಣಮಟ್ಟದ ಕಾಂಟೂರ್, ಬೀಚ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಪಡೆಯಬಹುದಾಗಿದೆ. ಇವುಗಳಲ್ಲಿ 1 ಪಿಕ್ಸೆಲ್ AERS ಹಾಗೂ NITK ಸಂಸ್ಥೆಗಳಿಂದ ನಡೆಸಲಾದ ಈ ಸಂಕ್ಷಿಪ್ತ ಅಧ್ಯಯನ ಡಾಟಾ ವಿಶ್ಲೇಷಣೆಯಂತೆ 1992, 2008 ಹಾಗೂ 2018ರ ಅವಧಿಯಲ್ಲಿ ಹೈಯೆಸ್ಟ್ ಸ್ಯಾಂಡ್ ಮಾಸ್ ಡಿಸಪಿಯರೆನ್ಸ್ ಅನ್ನು ಕಾಣಬಹುದಾಗಿದೆ. ಈ ವಿಶ್ಲೇಷಣೆಯಂತೆ 3.98 ಮೀಟರ್ ಪರ್ ಇಯರ್ ಹೈಯೆಸ್ಟ್ ಅಕ್ರಿಷನ್ ರೇಟ್ ಹಾಗೂ 19.59 ಮೀಟರ್ ಪರ್ ಇಯರ್ ಹೈಯೆಸ್ಟ್ ಎರೋಷನ್ ರೇಟ್ ಅನ್ನು ಸಹ ಟ್ರೆಂಡ್ಸ್ ಹಾಗೂ
Let me just close this. So here what I intend to demonstrate is local government's one issue, because how do we put small dams, where it should be put, and what need to be looked at. Normally it is more a political decision. MLA or MP or maybe a ward member, if they are strong, they will say no, it has to be here. But can we introduce more technical input and make a correct decision? How do we involve our students in such activities so that they get to know about what really need to be done in such situations? And they also get input from local people, the problem which is explained, verbal explanations, how do we convert that into an engineering problem statement and find appropriate solutions, and or find all the solutions and or choose the appropriate solution or an apt solution and then implement it. While implementing it, they will also say just a civil engineer may not be enough. They need to collaborate with different kind of streams. So how do we do that? There are people who are coming in from fisheries department, and many areas they come together because this is water body. If we do something with water body at one place, there could be an ecological effect in other places. All that integrated study happens, and that is presented as a small video here. So let us see another area where we looked at is hydrological performance of the Vended Dam. This again we have made the students to use all the technology available in NIDK to make sure that they implement most of the things. That will be an video advertisement. We'll just get out of this. Yeah, I'm sorry. This again for Karnataka, hence for Karnataka government, it will be in Kannada. Now, I would also like you to look at the way in which the students and the team has visualized it. So their creativity are getting used. If someone is interested in videography, someone is interested in video editing, it's all done by students and staff members of Center for System Design. And all the staff members are also students because they are JRF or SRF, etc. So how these rivers can be used and how do we make use of it without an ecological impact, etc., are the one which they are studying. You should be able to see all this in Center for System Design's YouTube channel.
ಉಳಿಸಿಕೊಳ್ಳಬೇಕು ಮತ್ತು ಅಭ್ಯುದಯವನ್ನು ಕಂಡುಕೊಳ್ಳಬೇಕು ಎಂಬ ಸದುದ್ದೇಶದಿಂದ ನಮ್ಮ ಘನ ಸರ್ಕಾರ ಸಣ್ಣ ನೀರಾವರಿ ಇಲಾಖೆಯಡಿ ಪಶ್ಚಿಮ ಜನರ ಜೀವನವನ್ನು ಉತ್ತಮಗೊಳಿಸ
3 ಮೀಟರ್ by 3 ಮೀಟರ್.
I'm just forwarding it here. I wanted also to show you what kind of technology interventions have gone in.
ಬೇಸಿಗೆ ಕಾಲದಲ್ಲೂ ಸಾಕಷ್ಟು ಪ್ರಮಾಣದಲ್ಲಿ ನೀರು ಮತ್ತು ಭೂಮಿಯ ಅಂತರ್ಜಲ ಮಟ್ಟದ ಅಭಿವೃದ್ಧಿಯಾಗಿ ಸುತ್ತಮುತ್ತಲ ಪರಿಸರ
How the underwater recharging is happening because of that.
ನೀರು ದೊರಕುವುದರಿಂದ ಕೃಷಿ ಚಟುವಟಿಕೆಗಳು ಹೆಚ್ಚಾಗಿ ರೈತರ ಆರ್ಥಿಕತೆ ನದಿಯ ಎರಡೂ ತಳಗಳನ್ನು
So you can compare it with before and after.
ಜನಸಂಪರ್ಕ ಸಾಧ್ಯವಾಗುವುದಲ್ಲದೆ ಮತ್ಸ್ಯೋದ್ಯಮವನ್ನು ಬೆಳೆಸಬಹುದಾಗಿದೆ. ಈ ಯೋಜನೆಯಡಿ ಗುರುತಿಸಿಕೊಂಡಿದ್ದ ಬೇಸಿಗೆಯಲ್ಲಿ ಸಾಕಷ್ಟು ನೀರಿನ ಅಭಾವವನ್ನು ಎದುರಿಸುವ ಮಂಗಳೂರು ತಾಲೂಕಿನ ನಿಟ್ಟೋಡಿ ಬ್ರಹ್ಮಸ್ಥಾನ ಕಟ್ಟೆ ಲಾಭ, ಉಪಯೋಗ ಮತ್ತು ಅನುಭವಗಳನ್ನು ಸುತ್ತಮುತ್ತಲಿನ ಪ್ರದೇಶದ ನಿವಾಸಿಗಳಿಂದ ತಿಳಿಯೋಣ.
So we did make the students to do a survey among the localites to find out the benefit out of this and things of that kind.
ವ್ಯವಸಾಯ ಮಾಡುವಂತ ಗ್ರಾಮ ಈ ಕಿಂಡಿ ಅಣೆಕಟ್ಟಿನಲ್ಲಿ 3.4 ವೆಲ್ ಮತ್ತು ತೆರೆದ ಬಾವಿಗಳ ರೀಚಾರ್ಜಿನ ಒಟ್ಟಿಗೆ ಕೂಡ ಆಗ್ತಾ ಇದೆ.
ರೆಸಿಸ್ಟಿವಿಟಿ ಸರ್ವೆ, ಲಿಡಾರ್ ಸರ್ವೆ, ಡ್ರೋನ್ ಅಂಡ್ ಫೋಟೋಗ್ರಾಮೆಟ್ರಿ ಸರ್ವೆ, ಬಾಥೋಮೆಟ್ರಿ ಸರ್ವೆ, ವಾಟರ್ ಅನಾಲಿಸಿಸ್ ಮತ್ತು ಗೂಗಲ್ ಅರ್ತ್ ಇಂಜಿನ್ ಟೂಲ್ಸ್ ಮುಂತಾದವುಗಳನ್ನು ಬಳಸಿ ನಿಟ್ಟೋಡಿ ಬ್ರಹ್ಮಸ್ಥಾನಕಟ್ಟೆ ಕಿಂಡಿ ಅಣೆಕಟ್ಟಿನ ಸಾಧಕ ಬಾಧಕಗಳ ಸಮೀಕ್ಷೆ ನಡೆಸಿ ಈ ಪ್ರದೇಶದಲ್ಲಿ ಆದ ಸಾಮಾಜಿಕ ಆರ್ಥಿಕ ಬದಲಾವಣೆಯನ್ನು ಗುರುತಿಸಿರುತ್ತಾರೆ.
So you can see the activities what is done in this are not just from one department. So if you are looking at it as a one department activity, so no, I am from civil, I should do only civil engineering, then the progress what we can achieve in order to find the solution of a problem will be limited. Obviously there are activities that can be done by each branch of engineering, and that will be, it can only give you a perfect solution if you bring in everybody together. Otherwise we will have the building kept ready, but it may not be useful because we have not taken care of the user intentions or user input and requirements. And quite often we feel that we know how it is working, but when it actually get in, it is going to be much different. I'll also show you some of the advanced approaches which we use for surveying. That could be an initial advertisement. This is a precision survey using LIDAR. Yeah, this is in English.
The wise consider time is money, and the DAR survey does just this, providing large and highly accurate data within a short period of time, which otherwise will take a huge amount of time or even when the area is inaccessible. So what is LIDAR? Light detection and ranging. LIDAR is a remote sensing method used to examine the surface of Earth. In this case, the device is mounted over an unmanned aerial vehicle to collect the data of the required area. Using the ground control station, the waypoints are created over which the drone has to fly. Monitoring of all the required sensors, drone health, ongoing flight progress, and GPS GNSS connection is done with the GCS. LIDAR and photogrammetry devices are merged together so as to get highly accurate and precise data. The images captured through photogrammetry are stitched together, analyzed, and the processed data is merged with the LIDAR data so as to get a highly accurate data set with RGB colors. From this we can get the orthomosaic map, DTM, DSM elevation model from which we can obtain detailed measurements of any point in the area such as cutting and filling, area calculations, volume estimation, etc. And this data can also be used for creating 3D mapping and printing. Differential GPS was used for the georeferencing of the whole project for centimeter level accuracy of flight planning. Experts suggest LIDAR will be the basic building block for all future systems, and the future is here.
That is about how the LIDAR survey and what equipment we are using. So we also had terrestrial LIDAR from Faro, and also 3D scanner. 3D scanner, especially when you want an existing building or maybe a small item to be scanned and reverse engineered or 3D modeled, etc. This can be used, and it can also be used for, we were also working with the group who are working on archaeological activity, archaeological survey and things of that kind, wherein items need to be scanned on the site and 3D model to be made, etc. So I'll just show you one image, one more video, and probably we'll not continue for more videos, but I'll just give you.
A lot of people don't believe me when I say I was working in a job 3 years ago, not having time freedom, not having financial freedom, no fulfillment, no joy.
I'm
Fast
sorry, this
forward
is
today, 3
advertisement.
years,
I need to wait for that advertisement to be
but
over.
I became a millionaire in just 3 years. A lot of people say, but Dave, how? How did you?
The required area. Firstly, a preliminary survey is conducted to get an idea of the site conditions to decide the placing of the instrument. The instrument is set on ground and the device settings are done, such as quality of scans, number of repetitions, etc. are fed before the commencement of the project. White spheres are randomly placed at various locations so as to get common points between different scans. After all these settings, the scanning is done for data collection. Similar scans are carried out at various locations of the site. For georeferencing of the whole project, differential GPS is employed. With the help of GPS satellite connections, the exact ground coordinates and elevation of the area is collected with level accuracy. Post-processing of the collected data is done with the ferrocene software. The scans are stitched together so as to get a photorealistic, virtual, 3D model in RGB format. From this data, we can carry out analysis such as area calculation, cutting filling, volume estimation, comparison of field measurements to its design drawings, 3D printed models, building information modeling, BIM, creating virtual reality, etc. Various surveys are conducted by NITK, Suratkal, using the FerroFocus S350 terrestrial LiDAR instrument. Beach profiling was carried out with the intention to compare the existing breakwater structure with its design drawings. LiDAR survey was also carried out at the dam site for correct area calculation and also to get the details of the inaccessible places in the site. Virtual reality was also deployed to the dam site model. This survey was also conducted at a quarry site to quantify the volume of rocks extracted and also to determine its surface area. Not only this, the aerial LiDAR data can be merged along with the terrestrial LiDAR data so as to obtain a complete 3D model of the surveyed area. Along with all these applications, it also has a lot of advantages such as high accuracy, detailed data collection when compared to other traditional survey methods such as total station, diverse application of the data collected, instrument is user-friendly and much more.
And was it just looking at only problems which goes out of the lab? The answer is not no, because we also made students to work together in the laboratory, because all the students may not like this field work. Remember, whatever you teach in the class with all the descriptions on and surveying using LiDAR or georeferencing, things of that kind, will not really get in unless they do it actually. And all the students obviously may not be interested in doing that. So we also had sufficient work done at the laboratory so that people who are interested to be there in the lab, they should be able to do that in the laboratory itself. So that way we provided mechanical, electrical and other students working together on 3D printed magnetorheological sandwich beams. It was an MTech research work which led to patents.
Are replaced by sandwich structures in order to make the system lightweight.
So it was a preparation of that material.
At the resonance condition, these structures tend to collapse.
It's magnetorheological elastomers he is making. It is fluid. Then he also does something with magnetorheological elastomer.
To this problem, magnetorheological elastomer, that is MRE, is embedded into the sandwich structures such that the stiffness of the sandwich structure can be changed under the influence of magnetic.
You can see how quickly the amplitude of vibration comes down. And it's a laboratory experiment, but this experiment had to be done with multiple teams together because it had involved.
Helps to avoid the failure occurring at resonance condition.
This is also part of our activity wherein the thesis need to be presented to the grandmother. That is, this is in 2 minutes to your grandmother. So many of us do research, and how do we tell what research we are doing to our grandmother? So we gave 2 minutes time, 120 seconds, to explain their thesis to their grandmother. So if you have to explain to the grandmother, you can't use too many technological terms. So that was a good exercise we did, and some of the students could do it quite well. Whatever we could get to show to the people, we have put it here. We are forcing every student to do this thesis in 2 minutes to the grandmother. So once you finish your thesis, make sure that you make a 2 minutes activity so that a layman will be able to understand what did you do and what struggle you have done and what is the outcome. So similarly, we had energy harvesting. So I'm not showing you those items as such because it's all available in the YouTube channel. You can very well have a look around the YouTube channel and pick up your choice and see whether it is interesting to you. And the requirement here is to make this happen at each one of your institute. It's not about NITK doing it or Center for System Design at NITK doing it. How do we make this experiential learning a reality in transdisciplinary work? So when when a solution to be found for a problem, the problem may not or will not belong to one discipline. So how do we put that together is what just people are looking at, and how we can engage our students in doing such activity and provide them much greater in-depth involvement and make sure every concept which they have learned are experienced. So probably with that, I will be just winding up the talk because I know it is a long 1 hour activity, but I would like if there are some questions to be, let me just see whether I can get my control back. Yeah. I'll pause the share, I'll stop the share. Yeah, you can. So this is what we looked at, how a problem statement from the real life can be converted into an engineering problem statement, and how do we find solutions. So first itself, the concept what people give may not be looking like a problem statement in engineering domain, but this can be put together and converted to an engineering problem statement, or technology intervention can be done. And how that is happening and how do we provide that experiential learning to our students is what we looked at. Few examples, I think we have more than 100 examples available in the YouTube channel. You are free to go and have a look around, and if you have some issues or some clarifications, we are always there to support you for any of this experiential learning activity. So thank you for the patient listening. So over to the host.
Sir. So thank you, sir. Thank you for the session. Shall we take some questions, sir?
Yeah. So I'm available for another 7 more minutes. So after that, I have another meeting.
Yeah, okay, sir. One hand raised here.
Yeah.
Mr. Asra Sultana. Can you please unmute yourself and pose the question?
I'm also open the chat window. If someone like to type some questions, that is also possible.
Yes, sir. I'm checking it, sir.
Go ahead, sir. If someone has a question or what hurdles you may find in your college, if you want to do it, etc.
Sir, actually, I think there are no more questions. So we can wind up this session, sir.
Yeah, now I'm just writing my email address as well as phone number. I use message or WhatsApp initially. If I'm in an online meeting, etc., we may not be able to pick up the phone, but you're always free to contact me. 9448.
Sir, can we take one question, sir?
Yeah, please go ahead.
Mr. Mohammad Akil Ahmad, sir, you can pose the question. I'm muting yourself.
Hello, am I audible?
Yeah.
Yes, sir.
Sir, thank you very much for the wonderful session, sir. Sir, my question is to you is, see, these projects we are seeing in NITs and IITs only. So I would like to know how to motivate the engineering students who are not studying in IIT and NITs. So they are You know these generations, sir, they are not much willing to do such projects. So I would like to know how to motivate them.
Yeah. Now, my first statement is going to be what I believe in my team and believe is a complainer cannot be a creator. If we keep complaining, we cannot be a creator. That is the first part. Okay. I will make three statements. One is a complainer can never be a creator. Second is we always find a reason to do rather than finding 101 reason for not doing. And third, every constraint is an opportunity to overcome the constraint and find a solution. Now, we also had this question. Many asked me the same way. So we did some experiments. We collected 45 students from all around different states, starting from Gujarat to Tamil Nadu and many states together as an internship. And we did an experiment with them. We randomly mixed. Okay, one student from, we made sure that from one state, only one student is there in that group, 5-student group we made. And you can imagine a rural Tamil Nadu student who was so comfortable with 5 students came from that college. They were talking in Tamil and they were put with one Gujarat, one person from Gujarat, one person from Rajasthan and such a team. And they had really and heart-burning issues in the beginning. So within 1 week, we saw them how they group together and start working. And we found there is always a way to do things. You motivate one student, 2 students, when they see things are happening, they will come. Obviously, they will have a short focus. I do agree with that because today they believe things should happen by flip of their finger. In the mobile, as the scene changes by flip, they believe that will happen. But we were lucky to get even students from the rural area, not belonging to NIDK. They came for internship. We could motivate them to work with. One question we never ask the student is, what is your grade? What is your mark? And I believe everyone can be used. If you say somebody is useless, the meaning is we have used them less. So it is not useless, used less. And that statement makes us to say that every student, we had a student who said, sir, technology is not in my hand, but tell me whatever you want, I will go and find out where it is available. I don't know the local language, but in Mangalore, if you want to get item, I'll go and find it out. This was a student who came from North India, remember. He said, you don't ask me to do mathematics, but for the project, what item you need, explain to me what is that you need. I will find out, I will get it for a much cheaper rate than what you can go and get. Look, that is a solution. I'm able to use that little finger also for my effective holding the project. So in that way, if you find things to do and passionate about doing, of course, you need a group of faculty members who are passionate about doing it. It will be out of classroom activity. It may not be counted for your promotion if there are something of that kind. It is out of sheer passion, you should be able to do it. And you need to be happy by accomplishing it rather than somebody else patting on you, say that you have achieved it. Why are we looking at outside for such things? If I can produce my own motivation and say happy about what we have done, even the rest of the world says it is useless, I still feel happy. So my answer to your question is, it is possible to do it in your college. Only thing is that starting, you will have more trouble. Be patient. This work we have started it in long back. If you want to get a milestone activity, 2001, after I finished my PhD from IIT Madras, I came. 2003, I proposed this center. It took 5 years for me to get an approval. So that is the gestation period. Okay, the idea conceived and carried, the delivery happens for when your gestation period is over. That happened after 5 years. So if you are a person who can drive yourself, have infinite internal motivation or self-motivation, these are the things to be looked at. Assume that you are a person who follow instructions and carry out instructions. That no, my HOD told me to do it and I am doing it. Then this is not the area, remember. So we need to look at it from that perspective. If do you have that kind of a motivation to work and achieve, then people coming around will obviously will happen. People will gather. It will be slow. From 2008, to this period, we have moved in 7 locations in NITK. That means the center itself have moved on to 7 locations. You will have troubles coming from every side, but make it as an opportunity. Whenever I had to move from one building to other, I moved on to a bigger space. So that was an opportunity for me. From one single room, now we have a very large area to be used for the center. So every one of the constraints, we could convert that into an opportunity. So that is a statement I would like to give it to you. Let us be not a complainer, let us be a creator. A complainer can never be a creator. So we will not complain. One, we will always find a reason to do. So let us find one reason to do rather than 101 reasons for not doing. Third, always convert the constraint into an opportunity and start working. People will come, sir. It is from our own experience. We are saying, we have seen it and it will happen. There will be a lot of difficulties. I do agree. It is not going to be rose petals around you. It is going to be hard, but it is worth taking that kind of an effort. Do you like to ask another question on that, or you are happy with my question, or you are okay with my question?
Sir, even I am also motivated with your words, sir. Thank you very much.
Yeah. And we see some questions. Self-funded institution cannot get involved in depth research, even having interest due to limitation of the fund.
Sir, there are some questions in chat box, sir.
Yeah.
Can we take them?
Yeah, please go ahead.
Sir, there is a question from Dr. Arun Kumar Mandal. Which theory acts behind experimental learning?
You are talking about the pedagogical approach. See, when the approach here is there are 2 or 3 individuals who have contributed in theoretical sense. If you are from a psychology background or pedagogy background, that is people who teach and the way in which you can impart information and knowledge, kindly refer to, you just look at experiential learning. It is not experimental learning, experiential learning. Getting experience about the concept is what we are looking at. So if you look at the muscle memory, I'm sure that Tendulkar have not looked at the ball and realized it is coming at this speed. It is going to hit at this location. The reflection is going to be at 40 degrees. So he calculates the distance and put his bat there. No, he has the muscle memory to say that, okay, he sees each node, the information is gathered, processed and acted. So that ability comes from the experiential learning. So that is, if it is in the sports, we call it as a muscle memory. But if you are in an engineering or a technology field, when you actually do it with hand or do it involved in it, it comes as a part of you. It becomes a habit of you and you will be able to use it. So that's how I like to answer it rather than giving you statements. Just refer to experiential learning theory. You will get first 5 links you get on Google will be sufficient to give you sufficient theory. A lot of work is going on. If you are from an MBA department or a school of management, things of that kind, there is plenty of surveys and research done in this area. Maybe we can have a separate session on that, not now.
Sir, can we take one more question?
Yeah, go ahead. One question.
Sir, Dr. Divya UK has posed a question. What is the distance the drone can travel from the person handling it?
Yeah, we are able to go take it up to 3 kilometers. It is limited by the RF range, radio frequency range. Unfortunately, when it is flying up, there is no obstruction. If you're from electronics, you can understand from antenna to antenna, there will be no obstructions as such. Hence, we are able to get up to 3 kilometers. But the safe is to get into 2 kilometer range. And we have done experiments in a very, very difficult situations wherein we have to fly. So it depends upon what kind of RF communication things you have. The last movie which I have shown, that LIDAR, etc., it's our own drone with items. Of course, motors and other things are purchased, but carbon fiber items and things of that can be made and tried out. Of course, it may not be as good as a commercial item, but the students got that experience of building it. And if somebody want to take it up to commercialization, etc., now they are involved and they can do it. Of course, as a teacher, I may not be looking at it, but there are students who got that inclination can take it up. So 2 to 3 kilometers is our range, and whatever we are running, 15 to 20 minutes is the battery which we will be able to get. And it normally, all the commercial drones have a safe back home position. So you can set a home position, it will come when the battery is minimum, it will come to that position. And it required a lot of effort to fly, understand, and use. Training and discipline condition zone is difficult. Yeah.
So that's it, sir.
Yeah, thank you.
Thank you, sir. Well, sir, shall we move to the next session, demonstration session?
Yes, sir. For the questions,
Yes, sir. So your voice is not clear, sir. So,
Hello. Yes, sir. I think we can move to the next segment.
yeah, thank you, ma'am.
Yes, sir.
So, dear participants, it's time for the continuation of yesterday's session on the demonstration and overview of HER labs for core engineering domains. And the topic will be led by Mr. Rajat C. Kutekar and Mr. Steven, our junior research fellows for HER labs at NITK Surathkal. Over to the team. Thank you.
Thank you, sir.
Hello everyone, my name is Steven, research fellow at CSD, NITK. Today I'll be going to present the mechanical domain labs. So I'll share my screen. Is my screen visible?
Yes, sir.
Can I get a feedback?
Yes, sir.
Yes, thank you. So for the mechanical engineering, in the broad areas of virtual lab, you have to go to mechanical engineering tab. So here you will find the different labs from different developed by the different colleges. So I'll be taking some labs from NITK Surathkal and then few labs from the other institutions. So initially I'll take I'll experiment a lab from machine dynamics and mechanical vibration developed by NIT Karnataka Surathkal. So here in the page you will get introduction about the lab. So here you can read about the lab, then experiments experiment under machine dynamics and mechanical vibration lab. So here you will be having multiple experiment under the MDMV lab. So further tab is target audience. So here it will give you an idea about who can take the course. So this is primarily for final year or pre-final year students. Also, it can be used for who is working on the field of acoustics. So here courses aligned, the lab is based on strength of materials, dynamics of machines, mechanical vibrations, so etc. So prerequisites, you need to have basic knowledge about the dynamic and vibrations, and software required is Adobe Flash plugin. Also previously it had few experiment were running on Adobe Flash Player. So now it has stopped working. So the non-Flash Player experiments are involved in the labs. So then you will be having feedback form. So here you can express your feedback. So I'll be going to the experiment tab. So here I'll be demonstrating free vibration of cantilever beam. So in the experiment, we'll find multiple options like theory, procedure, quiz, simulation, assignments, etc. So in the theory part, you will get to know about the objectives of the experiment, and here the objective of the experiment is to calculate the logarithmic decrement, damping ratio, damping frequency, and natural frequency of the system. Also calculate the damping coefficient of the system. So a later stage you will get introduction about the uh, cantilever beam, then formulas associated with the experiment. So you can go through it. You can read once. You'll get to know about the experiment. Then second tab is procedure. So this will explain us how to conduct the experiment, that is how to run the simulation. So this will be having formulas to find out the various parameters. Uh, so here you will get the detailed procedure to conduct the experiment. So here you will get beam stiffness, how to find the formulas to find the beam stiffness, and then natural frequency formula, then equivalent mass, then critical damping, and uh, finally we'll get a result. So the next tab will take us to the self evaluation, that is quiz before simulating the experiment, or it is to check our knowledge on the experiment. So here I'll take a few examples. So here the number of cycles per unit time is called the dash of vibration. So here anyone can answer the question in the chat box, or you can unmute your mic. Okay, the answer is frequency. So similarly, you will get a few more questions. You can answer them. Uh, then you can move on to the experiment by clicking here. So here the next tab is simulator. So here you will, as I said, we have to go to the explore for the non-flash users. So here this is a animation window, and this is a variable window, and this one is a control window. In the variable animation window, you will get the simulation of the experiment. Also in the variable window, you can vary the parameters as required by you. Then the length of the beam you can change, damping ratio, end of mass you can change. In the control window, you can pause or play the simulation. Also you can get the graph from the experimental values. So here this will give a brief idea about the mass of the system, and spring stiffness, coefficient of damping, natural frequency, and damping frequency. So in the first one, it will explain the cross section or the material. So on moving the cursor above the picture, you will get to know the parameters of the beam, the properties of the beam. So uh, here we'll be using ISMB 100 beam I section. So it will give you an idea about what is the height, what is the breadth, thickness, and the moment of inertia. Also the area of cross section of the I section. So here you will get the you will get the mass of the system, and then spring stiffness and damping coefficient. Then here you will be having a beam with the end mass. So when I click on play button, so it will come to rest. So before that, here you will be having multiple materials option for the steel and aluminum and bronze. Then in section, you will be having I section, T section, C channels, L section, and square section, circular, etc. So you can vary the length required as required, and then the damping ratio and the end mass. So when I run the simulation, so since the damping ratio is 0, the system will not come to rest. So once I vary the damping ratio, the system will come to rest in some time. So here you will get the graph for it. So this is the displacement versus time graph. Here you will find the you can find the natural frequency, logarithmic decrement, etc. the values, and then here you will get the damping frequency from the amplitude versus frequency graph. Uh, so we'll move on to the next section. That is this one is a explore phase, where you can explore the experiment. In the experiment tab, you will be having constant values material is steel, cross section is I section, and the length is 1500 is already defined. Here you have to calculate the values by using the formulas available in the procedure. Now I'll run the experiment. So here you will get the graph, that is displacement versus time. So here you have to find the logarithmic decrement from this graph. So we can find it using the procedure available. So here you can see the logarithmic decrement has a formula of delta is equal to 1 by n ln x naught by xn, x1 by xn. So here x1 and xn refers to the displacement at the first and the nth peak, and n is a number of cycles. So we can go to the simulator. So now I'll move on to the cursor to the second peak. So the value is 38, and next peak is value is 14. So I have calculator, and I'll calculate the value. So even audience also can answer the question. So by using this formula, 1 by n ln x1 by xn. So the first peak is around 38, and the second peak is around 14. So number of peak is 1. So here I'll get the value. Sorry. So somewhat 0.96 I'm getting. So it will take the actual value. So the answer, if the answer is correct, it will show the right tick, or else it will show the cross mark. You will get real time value for your experiment what you have conducted. So next one is you can also restart the experiment, and the values will change. Now the cross section is square section. It has taken steel as a material. So for every restart experiment option, you will get the new material, new cross section, and the length, as you can see. So I'll move on to the next experiment in the second experiment. So that is to find the, so this interface is same for all the experiment. Expect the variables will change. So I'll start the experiment, and I'll get here material as bronze, square section, and length is mentioned over here. So for the damping ratio, so here we have to find the damping ratio from the logarithmic decrement. So here we have to first find the logarithmic decrement by using the formula 1 by n ln x naught by xn. By using this cursor, you can take the values, and then we have to find the damping ratio, that is zeta. You can check the formula over in the procedure. So here you will find the formula zeta is equal to 1 divided by square root of 1 plus 2 pi by delta whole square. So using this formula, you will get the damping ratio, and you can enter the value over here to check the whether your answer is correct or wrong. So then again you can restart the experiment to get a new material, a new cross section. So and the length. So I'll move on to the third experiment, that is to find the natural frequency. Natural frequency from the this one, damping frequency and the uh, damping coefficient. So here when you move on to the move the cursor on the peaks, you will get the values. So for the natural frequency, the formula is over here omega d divided by square root of 1 minus zeta square. So for this you have to find the logarithmic decrement, then damping coefficient, and then you have to calculate the natural frequency of the system. So then you have to enter the value in the checkbox, and you can cross verify your answer. So this is for free vibration of cantilever beam. I'll take one more one more experiment from the different lab. I'll take mechanics of machines developed by NITK. So here also you will get the same tabs in the labs. So here you'll get the introduction about the lab, then experiments, target audience, and the feedback form. So here I'll move directly on the experiment tab. So here I'll explain elliptical cam mechanism. So here you will get the theory about the elliptical cam mechanism experiment. So you will be having different cams, the cam nomenclature, etc. So you can go through it, and then the procedure to conduct the simulation. So here you will get the details about the procedure to conduct the simulation. Then the self-evaluation. I think this lab is under development. So in self-evaluation, you will get the quiz related to the experiment, and then in the simulation part, so So here you will get the, so this is the animation window. So it will be having a cam followed by the follower. So here you can vary the length. So this one is a major axis, and this one is a minor axis of the cam. And here you can vary the angle also. So you can see at what angle. So here you can vary the angular velocity of the cam. So here you can see in the graph, you can show the graph, and then you can start the experiment. So here you will get the position of the follower at 340 degree. It is 6.52 and minus 6.52, and the velocity associated with it, and the acceleration and the jerk you will get with respect to time. So this is a simple experiment. So then moving on to the next tab, that is assignments at to update, and the quiz is also at to update. And then videos, you can get the Lagupata videos about the experiment. You can go through it. It will explain in details, so you can go through it. So you will get the references for the experiment from the book, or they'll write the website in this tab. So you'll get the feedback form about the experiment. So moving on to the next experiment, eccentrical cam mechanism. Here also, this is a similar experiment to the elliptical cam. So I'll move on to the simulation. So here you can vary the distance. So you can vary the eccentricity and the radius of the cam. So here also you'll get the graph. So you can know the position of the follower, and the velocity, and the acceleration and the jerk with respect to time. So next I'll move on to the one more lab. I'll take micro machining lab. So here you'll get the introduction about the lab and the list of experiment. So here I'll take wire ADM process. So the aim and objective is to study the significance of the process parameters, that is voltage, current, pulse, on and off time on the wire ADM process. So in this pre-test, you will be having a few questions. You can go through the theory part. You will come to know about the process and the influence of the pulse parameter, effect of frequency on the process, then influence on of wire positioning, so effect of wire tension, etc. So how these parameters will affect the wire ADM process, you will get to know in the simulation part. Coming to the pre-test, so here this will be having quiz, so I'll be answering few. So here wire ADM process is used for so cutting operation, and then the tool is of the form is wire in the wire ADM process, and cutting off very hard electrically conductive material in the EDM can be performed using I think all of the above. The dielectric fluid used in the wire ADM is generally deionized water, and in CNC wire ADM are generally Normally it is all of the above. In all axes you can get. So I'll submit the test. You will get the real-time answer. So the answer is correct for all the question. You can also view the solution. You'll get the answers for the questions. So I'll move back. So next is prerequisites. So you need to have a basic knowledge of wire EDM process and the various technologies related to the pulse. Then theory, then experimental setup. So the wire EDM process setup will be like this. It will be having display, wire, and dielectric material, and then you will get the specification of the setup. So here you'll get the maximum workspace size and the feed rate, wire electrode diameter, etc. You can go through the details, and then we get the simulator part. So it will tell click here for the simulator. So I'll move on to the simulator. So this will be having control panel and the diagram of the setup. So it asks for 5 trial for the graph. So in the first trial, the voltage is 45 to 80, and the machine runtime is 4 minutes 36 seconds, and the on time is 0.25 microseconds. Off time is 128 microseconds. So I'll add this. So here material removal rate is 2.4 millimeter cube per minute, and the surface roughness is 1.02 micrometer. Similarly, I'll add a few. I'll run the experiment. Okay. Then we are having a graph. So it is asking you must select at least 5 readings to plot a graph. So I'll select few 5 values. So next is the material removal rate and machine time will change. So next I'll take 2 or 3 more values. So I have selected 5 trials. So now I'll plot the graph using plot graph option. So it will ask which graph to plot, on time versus material removal rate, or on time versus roughness, surface roughness. So I'll plot the graph. So you will get the graph that is experimental value. So the blue color line is experimental value, and the red color is theoretical value. So it is almost same. So you'll be getting material removal rate versus time graph. So you can also print the graph for your reference, and you can also download the graph. So I'll press escape. Then I'll plot the on time versus surface roughness. So you'll get the experimental value and theoretical value. So this is the wire EDM influence of the process parameters on the wire EDM. So then I'll move on to the next lab. That is, I'll take 3D printing virtual simulation from Dialbach Institute. So here in the introduction, you will get to know about the 3D printing lab. So what are the technologies associated with the 3D printing? How which one is more feasible? So next I'll move on to the objectives of this lab. So the students will be able to identify and describe the functions of different parts of the 3D printer, that is anatomy. Student will able to use the simulator and assemble the different parts of the 3D printer, that is simulation. So similarly, you'll have multiple objectives under the 3D printing virtual simulation lab. So I'll move on to the list of experiment. So here I'll demonstrate simulation of stereolithography process, so SLA process. Here you'll be having introduction about the SLA process, how it will be carried, the process diagram, material for the SLA, and the application areas where it can be used, and the advantages and disadvantages of the SLA process. So next is pre-test. After reading the theory part, after having the knowledge of SLA process, you'll be guiding to the quiz part. So here I'll answer a few questions. So which file format is used for storing the information of the surface excluding texture and color? So here the format is STL, and then SLA technique is based on the principle of polymerization of photosensitive resin. So why only certain polymer resins can be used for SLA process? Because photopolymerization is to be performed. So key difference between SLA and micro stereolithography process is resolution. Which of the following is an advantages of SLA process? So accuracy and surface finish. So let me submit the quiz and check for the answers. So my out of 5 I got 5. So next I'll be moving to the procedure. So here you will get how to conduct the simulation, and then I'll move on to the simulation part. So here on clicking you'll get the axis in the SLA process. You'll be having a container and then laser beam setup. So laser beam will coincide on the contact lenses, and it will so it will fuse the material that is resin. Then liquid photopolymer, that is resin, will be having in the container. Then platform, so it will be having a platform. Once the laser beam will as you can see, the laser beam is depositing the resin, that is fusing the resin, and the platform is moving down, so the part will create. So as you can see, I have started the process and I'll stop the process. So you'll get the part from the SLA process which are having high accuracy and surface finish. So this is for SLA process. Similarly, for I'll take one more experiment, that is user deposition modeling. So in FDM process, you'll come to know about the introduction part and working principle, etc. You can read it. Then the pre-test. So FDM technique is based on the principle of so extrusion of molten plastics. So in FDM process, the filament will get melted and guided through the extruder. What function of extruder nozzle? What is the function of extruder nozzle? To extrude the material. Which of the following material can be used for FDM 3D printing? So here all the materials can be used for FDM process. How many types FDM printers are available? Normally there are multiple kinds. me select 3. Which of the following is not an advantageous of using FDM process? So comparative. So excellent surface finish. So okay, answer is correct. So in FDM, surface finish is quite low compared to the other processes. So next, moving on to the next, that is a procedure, how to conduct the experiment. Then the simulation. In simulation, initially the you'll be having base. So here the build platform, upon that the model will be developed. So either the base will be normal base or the heated bed. In the normal bed, we have to maintain the temperature around the surrounding, otherwise it will the model will get warm. In the heated bed, we have to maintain the temperature, certain temperature, that is 60 to 120, 60 for PLA, or above about 100, 120 for ABS. So we have to, for the ABS, we have to maintain the environmental temperature in certain level, otherwise it will get warm. So next thing is extruder. So extruder will be having the extrusion head will be should be heated to get the filament out from the extruder. And the extruder end will be having nozzle through which the material will come out. The third is material spool. So normally it will be having PLA, nylon, wood, ABS, etc. Multiple filament can be used for the FDM process. It will be fed to the extrusion head. From there, through the nozzle, the material will come out after melting. So like this, the material will be fed into the extrusion nozzle. Then we will start the process. So once the one layer is formed, the build platform will move down, and the next layer will be formed. Once the model will be formed, we can stop the process. Normally in printers, automatically it will stop the process. So like this, we can get the a 3D printed model using FDM process. So here I'll stop presenting. My next few labs will be demonstrated by my colleague. Yes, thank you. Hello, Shrestha ma'am.
Yes, Stephen. I think Rajat can take over from now.
I think Latish is taking the next session. Can you please unmute him?
Yeah, sure. I request Daniel sir to make Latish the co-host.
Yes, ma'am, it's done. Please co-host now.
Yeah. Hello, am I audible now?
Yes.
Yeah, Latish.
Yeah. Thank you, sir. Yeah, is my screen visible?
Yes.
Good afternoon. Research genetic. So, Steven of the lab under mechanical engineering core areas. So, in the there is FM and hub. So, I will be FM lab. Fortunately, there are working labs under heat transfer, the master. So I will be done the FM.
Hello, Mr. Latif sir.
Yes, sir.
Your voice is breaking.
Check my internet. Hello, am I?
No, sir, it's not clear. It is breaking.
So the rejoin the maybe.
Yeah, yes, sir. Please rejoin again.
Hello, sir.
Sir.
Yeah, I am not able to join from my PC. I will be demonstrating from Steven's PC set.
Yeah, okay, sir. Okay.
Yeah. So, as I was saying, there are no labs on heat transfer right now, which are currently working. But there are few labs on fluid mechanics. I will be demonstrating them. So, in the virtual labs website, I will go to the virtual labs website itself. So, few of the labs which comes under which are common to both mechanical and civil engineering, they are in under civil engineering broad area, not under mechanical engineering. So if I go to civil engineering broad area, if I scroll down, I can find fluid mechanics lab.
Sir, your screen is not visible.
Yes, sir. Is my screen visible now?
Yes, sir, it is clear.
Yeah. So as I was saying, so few of the labs are both common to mechanical and civil. So I'll find labs like fluid mechanics under the civil engineering broad area, not under mechanical engineering. So if I click on that and if I scroll down, I can find the fluid mechanics lab by NIT Kisratkar. So I'll be demonstrating one of the experiment in this lab. So if I click on it, so the interface is very similar as previously explained by Stephen. So I'll get introduction to the lab. I'll get all the experiments under this lab. There are 5 experiments in this lab. I'll get the target audience, the course aligned, prerequisite, and feedback. So which is very similar to what Stephen has already explained. So I'll go to the experiments. I will be taking one of the experiment. Let's go to calibration of V notch. So again, in this experiment, again, the interface is very similar. I'll get theory regarding this particular this particular experiment, detailed theory about the notches, how calibration is done, all the required formulas and calculation. I'll get a procedure. So this procedure is for the how to conduct the simulation, not related to the uh, conventional lab. So step by step, along with the pictures, and uh, I'll get on how to conduct this simulation. So before going to the simulation, it is a good practice to go through the procedure. So, and there are a few questions, self-evaluation question for the student before he starts the simulation. Uh, uh, Again, there are assignment quiz videos, Lagopata video, where a detailed explanation of the simulation is given, reference and feedback. So in the simulator, this is the interface of the simulator. So here I can see a person standing next to the device to calculate for the calibration of V notch. So the objective of the experiment is to find the coefficient of discharge of V notch. So these are the apparatus used. So I'll click on next button given over here. So the first step is to press the start button. I will do that. So the simulator will give each step here. So if I just need to follow this. So the same procedure is done in this conventional lab also. So now it is asking me to open the inlet valve and allow the water to flow. So I'll open it. So there's a valve over here. So it is zoomed over here, and you can see a person opening the valve. Next, I have to note down the theoretical discharge of the V notch. So I have to find the head of the water. So the formula is given, that is final reading minus initial reading. So I'll get around 5. So I can try to answer this question twice before, and the simulator will give the result itself. And I have to calculate the theoretical discharge. The formula will be shown here itself if I hover over it. So I will enter some value. Again, I can try to, I have 2 trials to get the correct value. Then the simulator will itself give me the value. I click on next. Then it is asking me to note the actual reading of the V notch from the collecting tank. So actual discharge I have to calculate right now. So the time required for the water to fill 10 centimeter of height is given. Using this value, I have to calculate what the actual discharge is. I will enter some value. I'll get the theoretical, actual discharge here. So this was the trial one. I got the theoretical discharge as well as the actual discharge. So I'll get the coefficient of discharge by calculating. So similarly, I have to do 3 more trials, and again the same steps has to be followed for the trial 2 and trial 3. So I'll quickly just do the steps. Again, here the steps will be given on how to do it. So I have to do one more trial. The steps will again remain same. So if I don't enter a value, a pop-up will appear. So I have to enter a value before I move to the next step. So after I've done 3 trials, I have to stop the pump. So and I have to calculate. So the characteristic curve will be given of actual flow rate versus the head. So this is based on the actual value that was conducted in the lab here at NITK. So I have to calculate slope K and coefficient of discharge. After I calculated, I can check with the values here given here. So this is the result I'll get. The coefficient of discharge is 0.63 for this particular V0. So similarly, there are 4 more labs, 4 more experiments in this lab. So you can go through them, each of them. And there are similarly there are more labs related to fluid mechanics, like fluid machinery labs and hydraulics and fluid mechanics lab by IIT Hyderabad. Let me go to one of the metallurgy lab that is in mechanical engineering. There's a lab called electron microscopy for beginners by IIT Kanpur. So I hope you have heard about electron microscopy. So this lab will give a brief introduction to that. So there's an introduction again. The user interface is slightly different from the earlier labs that were explained. Here the contents are vertical instead of being horizontal. So again, the content will remain same. I'll directly go to the list of experiments. So there are around 10 experiments. I will go to one of them, basic of scanning electron microscope. So again, same thing, aim, theory, pretest, procedure, simulation, post-test, reference and feedback. I'll directly go to simulation. Here, one more thing, in theory, there is a video of electron microscope, how it works, detailed theory is given, and also theoretical explanation is also given here. So I'll go to simulation. So this lab has a voice introduction. So it is very unique compared to other lab, and I can interact with each part of the electron microscope here. So if I click on this, I'll get a one-line description of each part. And again, here the instructions will be given to me. So the simulator is asking me to switch on the power button, and the power button is here. I will do that. And every time I do a correct step, a notification will pop up over here. So now it is asking me to place a material. I will drag here, and it is asking me to place the material here. I will do that. Now it is asking me to set the vacuum level. I will set it at high vacuum. So for a human hair, the vacuum should be at low vacuum. So the notification is telling me to set it at low vacuum. So I'll do that. I have to select the accelerating voltage. And if you had observed, when I set the vacuum to low vacuum, the vacuum is being created here. So I'll select one accelerating voltage. Then I'll turn on the beam. So a small animation will be played of a beam turning on, and the image that we will get from an electron microscope will be displayed over here. And this image I can save it for later for comparison, or I can magnify it. I can change the brightness and contrast. So according to the according to what the student required, you can change the brightness and contrast and save this image for future reference. This was the second electron mode under scaling electron microscopy. I'll go through one more lab in the same, one more experiment in the same lab. Let's say feature size measurement, porosity, gain and reinforcement. So under simulation, I'll go to identify porosity and reinforcement and select a secondary electron mode. I'll load the sample. So vacuum is being created and the beam will turn on now. So I'll get an image. I can change the focus. So now it is out of focus. So I have to set the focus. So yeah, now the image is very clear. I can change the contrast so that the porous sections will be clearly visible. Yeah, now it is somewhat visible. Yeah, now it is asking me to click on the sections where porosity is seen. So here I can clearly see there is a porosity in C, D, and F. Yes, F. So I'll click on that. I'll check my answer. Yeah. So the porosity is present at CD and F. So yeah, this was a feature size measurement under scaling electron microscopy. Similarly, there are many more labs under mechanical engineering. So I would request the participant to go through other labs. I'll stop sharing my screen. So if you have any queries, you can ask now.
Hello, Daniel sir. Now this we have completed our presentation from our end. Session is open for question and answers.
Sir, currently only the 4 materials that were available can only be loaded to the sensor. The 4 materials that was displayed. So the samples that were already displayed are being loaded. Experiments or labs, anyone from anywhere around the world can use this lab. Yeah.
Sir, there is one more question from Palaksha Reddy K. How to develop these labs experiments? What softwares are used?
Yeah, so brief overview on the development of these labs will be provided in tomorrow's session, sir. Development of these labs is a vast procedure, including multiple rounds of evaluation and so on. So a brief overview will be provided tomorrow.
Okay, madam.
Yeah, and there was one more question with the installation of VirtualBox. So I have pasted 3 links in the chat window, one with the step-by-step documentation and 2 for the downloads. So to quickly summarize, first you need to download VirtualBox. Second download is with .ova file of 3.09. Hello.
Yes, ma'am. Please go ahead.
Yeah. So first you need to download both this VirtualBox and .ova file. And once you complete the download, first is you need to install VirtualBox. Then inside that you need to import .ova file and proceed with the installation of customized Ubuntu inside VirtualBox. So this is the brief procedure. You can refer the documentation.
Okay, ma'am.
Yeah, so I think, and also we had done the detailed demonstration on day 1. So the video might be, I think the video will be shared to the participants.
Yes, ma'am. We'll do that.
Yes, sir. Yeah. Thank you. So Beryl, do you want to add any additional points?
Beryl, sir, like to add anything?
Yeah, sir. I think we will and good. If there are no further questions, maybe we can go on to close the session. Like I was going through the chat box, so one of the questions was about using the labs from anywhere. Yeah, it can be used from anywhere around the world. You simply need to have a web access device, internet device with web access and the suitable plugins, like in case any of them are required. Generally, HTML5 and JavaScript is the development tool that is used for creating labs in the present state. So only 4 tools are being used. Just to briefly answer the other question regarding tools that are used for developing these labs also. And we'll, as Rita has already mentioned, we'll give a brief summary of that in tomorrow's session about how the development procedure of virtual labs is being undertaken. And yeah, I think that's just to summarize it. And Manual Pro for installation in laptop and Android phone. In fact, if you are mentioned about VirtualBox, the VirtualBox workaround can be worked out on a PC or laptop only. It won't be possible for an Android device as of now. So you will require a PC operating system that supports VirtualBox. Basically, that VirtualBox is the requirement for that case. So that is just for 350 odd experiments that are yet to be upgraded to HTML5, as they have already mentioned. And until that the point of time, they are upgraded to presently HTML5 versions from the existing Flash background. So until that time only this particular workaround will be, but once they are all upgraded, you can directly access them on your browsers itself, just like the other labs.
Thank you, sir. So there's another question from the chat box. Is it possible to work on microfluidic lab virtually as a master's or a PhD student?
I think any of the persons can answer that if that lab is available or not.
I mean, it might not be that lab. Any other lab, can we use it virtually as a master's or a PhD student?
Yeah, as far as users are concerned, it is for anyone. You necessarily need not be a graduate student. You necessarily need not be a student or teacher also. Anyone can use the resources. So there is no access restriction whatsoever. It's just like browsing through a YouTube set of YouTube videos or on any other platform. It is even YouTube requires you to have a Google account. Here you don't have that requirement. You just need to have a device with it.
I think the question was what that person meant was whatever values that we actually get in the virtual labs, can we use those values maybe in a PhD or a master's thesis? That is what.
Okay, PhD and master's thesis, I think it might be a little more complicated thing, like a experiment for your BTech or graduate level practicals. Most probably it should involve some practical aspects as well. So virtual labs are basically for a demonstrative purpose. That's one aspect of it. So there will be some amount of ideality involved, or the error factors. So whenever you are doing an experiment in real, you will be having several environmental factors. So a master's or PhD level work will take into consideration all those things, I suppose. So maybe it won't be that useful for that level if you are doing a research or something like that using virtual labs, but definitely for a demonstrative purpose, even for your research thesis or something, if you want to demonstrate how a thing is working in the ideal case and you want to show something different, a model of your own that is based on this particular work, something that you're creating as an add-on from the VLab simulations, probably you can use it at a better level.
Okay, sir. Thank you. Another question from one Mr. Palaksha Reddy K. Why should be added in the lab experiments? The lab experiments are static. Maybe it was a suggestion, I guess. Why should be added in the lab experiments?
I'm actually searching for that question. Sir, can you repeat that question?
Why should be added to the lab experiments instead
Okay,
of being
voice,
static?
I found that. So
Yes, sir.
voice is not added because we want to keep the simulations as light as possible, because we are trying to reach out to the entire academic community in the country. So that means there are a lot of areas where still we haven't been able to provide maybe 2 Mbps or 5 Mbps internet connectivity. So with VLab, we are trying to cater to those who are having only 2G networks even. So since we are trying to address such kind of an audience, a diverse audience across the country, we've tried to keep the simulations as light as possible, which is why we haven't included anything like additional voice or click to I think yesterday during Ashika was also mentioning answering a similar question. I think it was about if we'll be able to provide some on-click description of various apparatuses or tools, something like that. Question was there yesterday. So this is basically the reason. Voice over, if we are providing it along with the simulations, it could become a bit too heavy for low bandwidth networks to be able to effortlessly show them off. So which is why that way it is not provided. But definitely there are add-on resources like the Legopada videos we have already seen. There are resources with some voiceover additional video tools. So those video tutorials can be downloaded and used. Things like that can be done. So simulations are kept as light as possible. Wherever possible, wherever required, we are trying to provide add-on resources like Legopada or even the other developers are doing tutorials like that.
Yes, sir. Okay. Thank you, sir. Another question from Ishwaraya Ravla, who says, can we do machining process or any material on machine like lathe or milling machine?
Lathe and milling, whether that lab is available, maybe Latesh or Rajat, if you're there, you can answer that. I think Latesh is not there in the list.
Maybe we can answer that.
Yes, maybe we can answer that. Maybe we can take that off card. I will try to get that answered later during tomorrow's session or through the other channels.
Yes, sir.
Yeah.
I think that's all we have from the questions part, sir.
Okay.
So if you can elaborate on tomorrow's schedule, we can call it today.
Yeah, sure. So in tomorrow we'll be having the demonstrations of labs continuing from here. So tomorrow we'll be demonstrating labs from the various sciences domains as well as the life sciences areas, biotechnology, biology, and the basic sciences, physics and chemistry as well. So these will be the specific areas that we'll be covering, we'll be looking at, and we'll also try to bring in the pilot initiatives of NITK, that is virtual tour as well as remote to get labs. We'll have a brief session on that as well, and we'll have another session covering briefly about the development of labs, how the creation of content for this platform is undertaken by the various participating institutes. So it will be a brief overview. As Shrestha has already mentioned, it is a very in-depth, elaborate process that takes several semesters and several years to create one lab that you see on that portal as it is there. So we'll give a brief overview on that as well. And so tomorrow being the final day, we'll have a concluding note as well, and a few other formal activities like a quiz. So probably Daniel, so you can explain that part as well.
Yes.
Of the formalities.
Okay, thank you, sir. Dear participants, there's an announcement for tomorrow, an important announcement. The online assessment test will be, the link will be posted right after the valedictory program. So tomorrow, after the sessions, we'll be closing with the valedictory program, and then after that, we will be posting the feedback link as well as the online assessment test. And the feedback link for today has already been posted. I hope you are all filling the feedback forms. With that said, we'll call it a day.
I think there was one final question
yes, sir.
From Alaksha Reddy sir about demonstration of required softwares. So required softwares, sir, as we have already mentioned, an additional requirement is only there for a few of the older labs, older experiments that are flash and other dependency based, which we have already done on day one. So if you were not listening to that session, probably you can have a look at the recordings for day one, and you'll be getting to see those resources there. And for the other labs, definitely there are hardly any requirements. You can look at the instructions for using that particular lab in the instructions or prerequisites dependencies area on that particular lab itself, and you should be able to get that. Most of the labs, especially all the recently upgraded labs, will not have any additional requirement, and it should work without any issues on any normal web browser. And the other question,
hello,
okay,
sir. Regarding conventional machining labs, currently there are no such labs available, but it is under development. It will be available within a few months.
Thank you, sir.
Okay, and another comment was about the last day session to be shifted to first day. So actually we started with an introduction about virtual labs on the first day, and following that we were going into detailed demonstrations of subject specific stuff, so that on the first day all the faculty members and students can take interest and get an idea of what virtual labs is conceptually at a conceptual level, and then going forward they can get specific ideas about their own areas. And definitely you'll always have access to the recorded version of this program, so that you will be able to have a look at what have been covered even afterwards. And I think that answers even Maheshwar Rangaraj's question as well. Yeah, Daniel sir, over to you, I think.
Thank you very much, sir. Thank you very much, dear participants. We are glad that you made it today. So let's meet tomorrow for the final day, followed by the valedictory function at right after the sessions are closed. And then after that, we'll be having the online assessment test. With that said, we will call it a day. We will see you tomorrow again at the same time, 10:30 a.m. See you all tomorrow.
Thank you very much. Thank you, sir. Thank you, team from
Thank you, sir.
IIT
Thank you.
Surat.
Thank you, everyone. Thank you to all the participants.